Hi, I am Nagashaktidhar. Today I am going to briefly explain the assignment that we have done as part of the Predictive Analytics Course 1. So let me quickly walk through the problem statement. The problem statement is the Chinese automobile company Geely Auto aspires to enter into the US market by setting up their manufacturing plant in the US to give a competition to the US and European car makers. They want to understand what are the typical factors that are affecting the pricing of a car in US market. Considering the Chinese market is different from the US market, they would like to understand the factors and predict the car prices accordingly. So the goal of the assignment is we would like to build a model that would predict the price of the cars based on the various independent variables. As the price of the car is a continuous variable, this problem is a linear linear regression problem. As there are multiple independent variables like car type, car body, fuel type, and the number of cylinders and the number of doors are affecting the depending variable, that is price of the car. So this problem can be categorized as a multiple linear regression problem. So let's quickly look at the data set that we have, that is in our hand, along with the data dictionary, and then walk through the code accordingly. Let me quickly present my screen to walk you through the data set and the code. So this is what the data set we have. There are various columns that we have, almost 25 plus columns, and it has a various values, and we have a data dictionary that talks about, explains what is that value, what is that each column, and whether it is a categorical or a numeric variable. So coming back to the code that we have written to build this model, so we quickly load the data set into the data frame and then perform a various cleaning and the EDA activities on the data set. When I say cleaning, we are checking for NA values and then checking for any outliers and all. And coming back to the EDA, we would like to creating a derived columns based on the car company, and splitting it as needed, and also binning them into the uh, appropriate categorical variables, so that we will we can be creating a respect to dummy variables for that. And next, we are creating the dummy variables. But why are we creating the dummy variables? The linear regression model works with only the numerical variables. So for each of these categorical variables, we need to create the dummy variables. In case of categorical variables where there are two levels, we have quickly converted into one and zeros. And however, there are multiple levels, we had to create the dummy variables. So once the dummy variables are created and appropriate binning is done, your end data set is ready for the modeling. So let's split the data set into the two parts. It's a 70% and the 30%, and the first 70% can be used for the training the model, and the 30% can be used to test the model. So let's start with the model building. So the LM function in the R will help us to create a linear model with all the independent variables that we provide. So we have created a data set with all the independent variables here. So why we have created with all the independent variables? The reason that we have created with all the variables is because there is a process of variable selection wherein you can select the variables. It has a two types. One is a forward variable selection and the other one is the stepwise variable selection. The stepwise has been followed in the industry very widely. It helps us to select the variables both forward and the backward. So by using the step AIC function, like we can quickly eliminate most of the variables and select the only the variables that could directly impact the pricing of the model. And once we decide the what are the variables that are affecting, so we can quickly check how the model is performing and also like what are the various factors that are affecting the model. And we have something called multicollinearity. Multicollinearity help us to look at the look at the variables which are used to build a model and mainly look at the correlation of these variables, and if any of these variables are highly correlated, it we can maybe ignore one of the variables to make the model more efficient. Let's quickly go back to the code. As I explained, we have used the step AIC function to eliminate most of the variables, and we have only chosen some of the variables that are suggested by the step AIC function. And once the model is ready, let's look at the summary of the model to see what is the adjusted R square and what are the significant values. So the T stars represent the significance of the variable. So if there are any low significant variables such as city, MPG and all, like let's start removing those variables. So you could also use the VAF function to understand the multicollinearity of the variables and eliminate the variables if they are highly correlated. So based on that, we will be keep building the models until we arrive a stage where all the variables are insignificant and the correlation between the variables is very less. So let's use this model to predict the values on it, predict the car prices on a test data set. Once we have the prediction values, let's look at the correlation between the test data and the prediction data. So this correlation basically helps us to see how close our prediction values are. And now let's calculate the R squared value. R squared value is the square of the correlation. So this, if the R squared value of the predicted values is less than 15%, so that means that we were able to rightly predict almost 85% of the data. So this helps us to predict the price of the cars and look at what variables are actually affecting the price of the car. So once we arrive at a stage where our R square value is less than 15%, we can say that these are the variables which are affecting the price of the car in the US market. So based on this recommendation, the automobile company derive, can actually arrive at a decision making on building cars that will basically based on these factors like aspiration, engine type, and stroke, cylinders, etc. So that is briefly about the assignment we have done as part of the PA1 module, and what was the solution and how it has helped to do the right decision making. Thank you.